Our most basic stoichiometry problem is a one-step stoichiometry problem, and that's where we're going from moles of one substance, so we'll just do mole 1, to moles of something else, some other element or compound within that reaction. Let's just take a nice reaction here of hydrogen reacting with oxygen. Remember, hydrogen and oxygen are two of my magic 7, my diatomic molecules that are always 2 when they're on their own. It's not their charge or anything. In oxygen's case, it does happen to be, but they're things that are unstable unless they're bonded with something very, very unstable, and tend to bond with themselves when they're on their own. Okay, these two react together to form water. Well, if you remember, the first step is always to balance. So if I take a look at this, I've got hydrogen and oxygen on each side. I've got 2 hydrogen on my reactant side, 2 hydrogen on my product side. Oops. I've got 2 oxygen on my reactant side, only 1 oxygen on my product side. So I can see right away that the thing I need to manipulate is my oxygen. I'm going to do that by putting a 2 as my coefficient in front of the water. That now gives me 2 oxygen, but I now have 4 hydrogen. So I need to put a 2 in front of my H2. Now I have 4 hydrogen, 2 oxygen, 2 oxygen, and I'm balanced. So first step is taken care of. Now I need some sort of problem because I need to know what I have and what I want. So number 2, I'm going to say that my given is that I'm starting out with 3.5 moles of oxygen. And I want to know how many moles of water that will give me. Now that I've figured out my balanced reaction and my givens and my wants, I can look and figure out if I need to determine any molar masses. Step 3. Well, for this one, I don't need any molar masses because I'm just going moles to moles. I don't have masses at the beginning, I don't have masses at the end, so none are needed. Now I can start working out my problem. So I see that if I start out with my given, which is 3.5 moles of O2, set up my fraction. I want to get rid of moles of O2 and get to moles of H2O. Well, I do that with my mole-to-mole ratio based on my balanced equation. So I see here that for every 1 mole of O2, I have 2 moles of H2O. This is my ratio. 1 mole of O2 for every 2 moles of H2O. So I can put these two values in a fraction in any way that suits me to get rid of what I want to get rid of and get what I want to get. Well, I see that I have moles of oxygen on top, which means I need moles of oxygen on the bottom so that it'll cancel out. And again, I'm using that 1 that we don't write here, but it is there, 1 mole of O2 based on my balanced reaction. On the top goes what I want, which is 2 moles of H2O. Now I can take my moles of O2, those cancel out because I have 1 on top, 1 on bottom, and I get moles of H2O, which is good because that's what I'm looking for, that's my want, moles of H2O. Now I just multiply everything that's on top, divide by everything that's on the bottom. My answer is 7. I get 7 moles of H2O if I react 3.5 moles of O2 in excess hydrogen.